Welcome to this lecture on elements of mechanical engineering. In this lecture, we are going to see what are the non-metals like plastics. Now, my name is D. Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Currently, we are in the third module of this Elements of Mechanical Engineering course, where we are studying different types of materials which are related to engineering. Now, in this lecture, we are going to see what are plastics and polymers. Now let us see what is plastic. So plastic is a metal. Sorry, it is not a metal. Plastic is a polymer or organic material having carbon as the common element in their makeup. See here, the key component of this polymer is carbon. When carbon is combined in different proportions or in different forms, we will get plastics. Different types of plastics can be obtained. And then organic materials are those materials which are derived directly from carbon and consist of carbon chemically combined with hydrogen, oxygen or other non-metallic substances, invariably having a complex structure. So this comes under the plastics and polymers. Entire thing comes under the polymers. It comes under organic materials. So whenever organic materials are dealt, we will deal with different elements like hydrogen, oxygen and other non-metallic substances. This is not at all metal. So all the non-metallic substances will be taken care by this polymers and organic materials. So some examples of this polymers or plastic is wood. Wood is a polymer. It is not a plastic. It is a polymer which is made up of long fibers. And then we have animal fibers, natural rubber, coal, having biological origin, and synthetic fibers, plastics, soaps, cutting oil, etc. So these are all different types of polymers that are available in the nature. Some polymers are available readily in the nature. Some polymers are manufactured, that is synthetic polymers are there. So plastic is one of those synthetic polymer where we are going to make a chain reaction by using some kind of technique, and we will prepare this plastic. Now let us see what is the classification of plastic. Now thermoplastics and thermosetting plastics, there are two types. First one is thermoplastic. Now let us see what is a thermoplastic and how it affects the preparation or making of this plastic, and let us see what are the properties. Okay, now thermoplastic are those which softens on the application of heat with or without pressure. So this is thermoplastic, but they require cooling to set them to shape. Now they can be heated and cooled any number of times, only they should not be heated above their decomposition temperature. Now see, from this definition, what do we understand? So thermoplastic is a material which can be heated below its decomposition temperature and it can be molded into a new shape. So it can be reused many times. So generally this thermoplastic is a plastic which has high thickness when compared to other plastics. So this high thickness will enable the plastic to be reused. That is why most of the plastic things, when even the plastic bags also, they should be made up of more than 45 microns of thickness. That is when they can be reused or they can be converted into another form of plastic. That is why thermoplastics are more atmosphere and environment friendly. They will not contaminate the atmosphere if they are recycled properly. So that is why thermoplastics has this unique property of reusability, and it can be converted into another shape and size also. They are highly plastic and are easy for molding or shaping. Okay, they are highly plastic and are easy for molding, shaping, and they have low melting temperatures and are not so strong as thermosetting plastics. So these are not strong than compared to thermosetting plastics that are another type of plastics. Okay, we are going to discuss about them also. And since they can be repeatedly used, they have resale value because they are made in such a good technique of polymerization, they can be reused. That is why they have resale value. Once they are used, they can be reused again after some process. Some commercial thermoplastics are polythene, polyvinyl chloride, polyester, and polytetrafluoroethylene. So these are the very good examples of the plastics which are being used. First one is polythene, which we see polythene bags. Polyvinyl chloride are the tubes are made up of plastic tubes are made up of this PVC. PVC pipes is a very common name where these pipes are used for pumping of water from one place to another place. And then we have polyester. So polyester is a material which is used to make cloths. So cloths and jackets are made up of this polyester. And then we have polytetrafluoroethylene, PTFE. Now this PTFE is very interesting one. PTFE, polytetrafluoroethylene. So this PTFE is prepared or manufactured or invented accidentally. See, most of the inventions in the history are made accidentally. Even the X-rays or any radiations like any inventions are made accidentally. So they are not prepared for this invention. So similarly, PTFE, it is a polymer made up of polythene. It is a polymer. This polymer is used for the coating of cooking utensils. Nowadays, we have all the cooking pans and frying pans which are coated with some kind of layer called Teflon. So the Teflon is made up of this PTFE, polytetrafluoroethylene. So it has two forms. One form is very safe and second form is very dangerous and it can cause cancer. So during its first invention, the PTFE has been manufactured in a bad manner. That means in a bad form, it creates cancer. And the people itself, they don't know they are preparing this bad kind of polytetrafluoroethylene. This was developed by a company that was based in USA. I don't want to tell its name, but at that time they have prepared this PTFE and unknowingly they found that this is very bad and it may cause dangerous health effects. Even then, they let this PTFE into the lakes nearby, and the people around the lake who drank that water or the groundwater which is near the lake, that is also contaminated and it caused complete destruction. Like people unknowingly they suffered with cancers and they were dead. So this PTFE in a good form, like when it is converted into Teflon. So this Teflon is very useful. Teflon can be coated on the cooking utensils and this is somewhat good than the actual PTFE that is developed back in those days. So this Teflon is very useful for making the cooking utensils sticking free. Like we can easily remove or stick, food would not stick on the PTFE coating. Okay. So that is why Teflon coated cooking utensils are used nowadays. So this is one best use of this PTFE, even though it has bad effects. Now it is modified and being used. And then the second type of plastics. So these are thermosetting plastics. Thermosetting plastics are completely opposite to thermoplastics. We know that thermoplastics can be reused. They can be reheated below their decomposition temperature and they can be used again and again. But they are not so hard. They cannot take loads. That is why we should go for thermosetting plastics. The disadvantage of this thermoplastic is this cannot be reused. It is done once, it has to be decomposed, like it has to be thrown out. So this is the disadvantage of this thermosetting plastic when compared to thermoplastic. So the advantage of this thermosetting plastic is this can be made stronger. So the plastic objects that are made up of this thermosetting plastic are stronger when compared to thermoplastics. Now, they cannot be resoftened once they have set and hardened. So once they are made into a particular shape, they cannot be reshaped or they cannot be reheated and they cannot be reused. They are ideal for molding into components which require rigidity, strength, and some resistance to heat. Okay. So whenever we want to make some objects that are very hard or rigid, like a computer or a CPU or a TV, the TV back part of the TV is made up of this plastic. So that is when thermosetting plastics are very useful. So when we make these objects with the thermosetting plastic, we can, they can, they can bear more loads. They can last longer. Okay. So they have more rigidity, strength, and some resistance to heat also. They do not have much resistance. They have only some up to extent, or some extent, they have good heat resistance. And then, in general, resins formed by condensation are thermosetting. So generally, if you take resins, if they are formed by this condensation process, then they are mostly from thermosetting plastics. And then thermosetting resins have three-dimensional molecular structure and have very high molecular weights. So whatever thermoresins are there, they have very good three-dimensional molecular structure. That means in 3 dimensions, they have a very good structure and they have very high molecular weights. Okay. Now let us see some important commercial examples of this type. Some important examples of this type are phenolics, polyesters, epoxies, silicones, etc. So these are the examples of thermosetting plastics. Phenolics. So these are mostly used for the pipes. In house wiring, we use some kind of cables. So the cables are made up of this thermosetting plastics. So they are called phenolics. And polyester. Polyester has again applications in both cloth making and also some kind of plastic objects are also made up of this the polyester. And then we have epoxies. Epoxies are nothing but very hard plastics which can be used to in some kind of composites also we will use epoxies. And silicones. Nowadays we have silicone which is added to rubber and we have silicone rubber that is used for preparation of belts for watches. Nowadays we are having smart watches which are attached with this silicone material. Okay, it is silicone rubber actually. It is made up of rubber which is combined with silicone. So silicone is a kind of thermosetting plastic. So these are some of the uses of different types of plastics, and we'll see what are the different types of classification of thermoplastics and their uses also. Now we have 11 of them here. So first one is polyethylene or polythene. So this is very popular. This is thermoplastic. So this can be reused if it is made under proper thickness. Okay. If its thickness is more than 40 microns, this can be reused. It may not be used to prepare a polythene bag again, but it can be used for other applications, like they can be used to make dolls or like plastic things. So this is polyethylene. This is mostly used for polythene bags, covers. And then we have two types of polythene are there. HDPE, high density polyethylene, and low density polyethylene. And high density polyethylene are used to prepare containers for milk, motor oil, shampoo. Like plastic bottles will be prepared by using this HDPE. What are the plastic bottles are there? So these white color plastic bottles which are used to carry oils, and shampoo bottles. So these are all made up of this HDPE, high density polyethylene. And then we have low density polyethylene which is used to prepare containers for containers, computer components, etc. Okay, all the plastic containers, computer boxes and the CPU boxes, they are all made up of this low density polyethylene. So when we compare, the high density polyethylene is weaker when compared to low density polyethylene because computer and container parts are more stronger than milk containers and shampoo bottles. And then we have second type of plastic, that is polyvinyl chloride, PVC. So we know PVC pipes are very popular. They can be used for running waters, pipes, power, data, telecom cables. All these cables are made up of this PVC. So PVC has the property of being converted into long tubes. It can be converted into very long tubes without losing any strength. So that is why PVC pipes are mostly used for running cables and pumping waters. And then we have polypropylene, PP. So these are mostly used to prepare ropes, tape, carpets, camping equipment, etc. Okay, so these are the general applications of polypropylene. When we take a plastic rope, it is made up of this polypropylene, which are used for hiking and extra. And we have Teflon or polytetrafluoroethylene. So this is a waterproof fabric coating for medical devices and cooking devices. So these are all made up of this Teflon. And then we have polystyrene. Polystyrene is used for making DVD cases. So in olden days we have DVD covers which are made up of plastic. So these are made up of this polystyrene. And then TV components, computer components are also made up of this polystyrene. And sixth one is acrylics. So polymethylene methacrylate, PMMA, polymethyl methacrylate. So this is used for paints. So even fake nails are made up of this plastic, and LCD screens, furniture are also made up of this PMMA. So this is very strong. Like we can make furnitures out of this. Okay, we can actually make furniture. So ABS, acrylonitric butadiene styrene. So this is mostly used for ABS material. Is used for automotive body parts. That means most of the car body parts and bike parts are made up of this, and helmets are also made up of this. So this ABS is also nowadays used for 3D printing of objects. Silicons are mostly used for sealants, adhesives, lubricants, cooking utensils. So these are the applications of silicons. And then we have polyvinylidene chloride. So this is used for packaging of meat, snacks, food, tea, coffee, etc. So packing plastic is called polyvinylidene chloride. So this is used for packing of food. So because it is highly volatile and it does not contaminate food, that is why it is used for packing of food. So polyamide. So this is used for clothing and carpets. And then we have bitumen. So bitumen is used for roofing, waterproofing and road construction. Bitumen is a kind of plastic which is used for laying roads. So mostly we will call bitumen roads when we are studying civil engineering. So roofing, waterproofing and road constructions are made with this bitumen. And then we have thermosetting plastics. So far we have seen thermoplastics, which are very soft in nature and they can be reused. Whereas these thermosetting plastics are not reusable. They have high strength when compared to other one. The first one is phenol formaldehyde. This is very popular. It is called as bakelite. So this is used for wire insulation, socket switches, etc. So all the electrical applications like electric switchboards, electric wires, etc. are made up of this bakelite. Okay. And then we have amine formaldehyde. Amine formaldehyde, as it is used as plywood. The preparation of plywood, where they will use this amine formaldehyde. And then particle board adhesives, laminated countertops, automotive surface coatings. So these are all made up of this amine formaldehyde. In different forms, they exhibit different types of properties. And then we have polyesters. Unsaturated polyesters are used for clothing. Okay. So polyesters are used in clothing, preparation of clothes. And epoxy resins. These are used for aircrafts and satellite body parts. So epoxy resins are generally, we study this under composite materials also, where we will study different epoxy materials. We will prepare different types of composites which are used in aircrafts and satellites because they have less strength and as well as they have less weight, more strength. And then another type of non-metal. So far we are studying non-metals, out of which we are studying plastics. So plastic is a non-metal. It is not at all a metal. It does not have the basic quality of being called as a metal. And then the other non-metal is ceramic material. Ceramic is also a good material which is made up of clay or soil, and it has it has to be undergo a process, like it has to be burned in order to gain strength. Okay, so these are defined as those containing phases that are compounds of metallic and non-metallic elements. The crude cooking utensils of early men were the first applications of the materials now used in jet engines and atomic reactors also. Now let us see how ceramic materials are first invented. In olden days, people used to cook food in ceramic utensils only. Mostly we know about a China type of ceramic ware, where they prepare different types of these ceramic utensils which are used for cooking and eating. So this is the first type of application where man used ceramics. Nowadays, the use of ceramics has increased and it has evolved. It has many uses, like it can be used as in the atomic reactors as lining. So we know in atomic reactors, large amount of heat has to be controlled, which is more than the melting point of any metals. So, or if we want to use some kind of insulation for furnaces, furnace is the place we are going to melt metals. So the temperature here has to be more than the melting point of the metals. So that is when we can use ceramics or jet engines where the temperatures rises very high. So no metals will withstand this high temperature. So that is why ceramic materials are very resistant to temperature. They can resist large amount of heat. So that is why they are used in jet engines and atomic reactors. Now let us see what is the classification of ceramics. So depending on the functionality, so they are classified into one type. So let us see what is the functional classification. Abrasives. So the ceramics can be used as abrasive materials like aluminium, carborundum, etc. So pure oxide ceramics, MgO, Al2O3, SiO2, these are pure ceramics. And then we have fiery clay products like bricks, tiles, porcelain, etc. So these are all the applications of ceramics. And then we have inorganic glasses, window glass, lead glass, etc. And then we have cementing materials like Portland cement, lime, etc. And then we have rocks, granites, sandstones. And then we have minerals, quartz, calcite, refractories, silica bricks, magnesite. So these are all the different types of this ceramic materials based on their functionality. So this is the classification based on the functionality of this ceramic. So when we see the functionality of this fiery clay products, so these are mostly made for construction like bricks, tiles, and then we also make porcelain material, because these bricks, tiles and porcelain, all these three, these are made up of heating. Like once they are getting to a required shape, they will be heated in kilns. Okay, they will be burned for some time, and after that they will be made very strong. So bricks, tiles and porcelain are the are the ceramics which are made up of fiery clay products. Okay, these are used for construction, and some are porcelain are used for teacups, etc. And then we have organic glasses like window glass and lead glass. So what is the difference between window glass and lead glass? So window glass is the glass which is attached for windows for making ventilation, whereas the lead glasses are nothing but the mirrors which we use in our homes to see our faces. So lead glass is nothing but or tinted glass which are used in cars. So cementing materials like Portland cement, lime, etc. these are used in the construction again. And then we have granites, sandstone. So these are also different types of rocks used for construction or laying floors. And then we have quartz mineral, calcite mineral. So these are all the material. So all these minerals have different applications. All these comes under ceramic materials. Okay. Now we have second type of ceramic material. This is based on the structure. So this is structural classification. So depending on the structure, the ceramics are divided into many types, like 4 types are there. Crystalline ceramics, non-crystalline ceramics, glass bonded ceramics, and cements. So these are the types of different types of ceramic materials by which, based on the crystalline structure, they are divided into 4 types. Okay. Now, type of cementic products. So when we want to show what are the different products that are made up of ceramic, now we have different objects like, first one is whiteware. Whitewares, bricks and tiles. Bricks are also made up of this ceramic. Chemical stoneware. Stonewares are also made. Cements and concretes are also comes under ceramics. And then abrasive particles, like the abrasive particles which are used for grinding the tools in machines lab. So that is also made up of this ceramic. And then we have glass, insulators, porcelain enamel, refractories, electrical porcelain, mineral oils, slags and fluxes. All these comes under ceramic products. Okay. And then let us see what are the advantages of ceramic materials. The ceramics are hard, strong and dense. Even though they are made up of sand and clay, they have very good strength. Not strong as iron, but they have good strength. And they have high resistance to action of chemicals and to weathering. So they are very atmospheric resistance. Okay. Even they can be used for centuries. Some old Chinese products which are made of ceramics. So these are long lasting now also, even though they are made up of sand and clay. So they also possess a high compression strength compared to tension. Okay. They have a very good strength when compared to tension, and they have a high fusion points. They have high melting temperatures. They offer excellent dielectric properties. That means they act as very good insulators. They are good thermal insulators also, because they does not make the heat flow through them, and they are resistant to high temperature creep, which is a bad quality of metals. So when a metal is subjected to very high temperature for a longer period of time, it will fail at a lower strength value than its actual. Okay, so this is the advantage of this ceramic. They don't have any creep. They simply work even at high temperatures. Availability is good because these ceramics are mostly made up of clay, sand or silicon, etc. These are mostly available abundantly in every part of the world. Good sanitation, so they can be used for sanitation also. Better economy. So because they are made with sand and clay, which are very less expensive when compared to other metals or materials. So ceramics are very economical. Now let us see what are the applications of ceramics. The whitewares, olden ceramics, these are used in tiles, sanitary ware, low and high voltage insulators. See this, tiles, we know, tiles are the things which are laid on the floor nowadays, and sanitary ware, most utensils like toilet ware, these are also made up of this sanitary ware, ceramics. Low and high voltage insulators. Now, what are these low and high voltage insulators? So, when an electric pole is laid, electric wires will be running over them. At that point, they have to place these ceramic parts which are made up of this ceramic. So, these are very good insulators of electricity, that they won't make the electricity to flow into the pillar, so that even though we touch the pillar, electricity will not pass. Okay, so these low and high voltage insulators are installed on every electric pole. And then we have high frequency applications, and chemical industries as crucibles, jars and components of chemical reactors, because ceramics will withstand very high temperatures. That is why they can be used to in the working of crucibles, jars and components of chemical reactors, etc. Okay, even these can be having more melting point than any metal. And then we have heat resistant applications like pyrometers, burners, burner tips and radiant heater supports. So these are the applications of ceramics, where ceramic is made up of sand or clay. It has many applications and it has very good temperature resistance property, where it can be used to melt metals also. These has the melting point that is more than the metals. And then newer ceramics are there. So these have high hardness values and heat. These are oxidation resistance. These are largely used in refractories for industry furnaces and electrical and electronic industries such as insulators, semiconductors, dielectrics are made up of this ceramics. And then nuclear applications as fuel elements or fuel containers. Okay, so in nuclear reactor we have the entire lining made up of ceramics only. Ceramic bricks will be there for the containing of fuels, fuel containers, fuel elements, moderators, control rods, structural parts. Everything is made up of this ceramic only, because the temperature inside this nuclear reactor will reach very high value. That is why we should use a material which is temperature resistant. Ceramics such as UO2, UC and UC2. So these are all combined with uranium, uranium oxide, uranium carbon and uranium dicarbon. So these are all employed for all these purposes. Okay, these are all used for nuclear reactor applications. And then we have ceramic metal cutting tools made up of glass. Okay, we have cutting tools also made up of this. And we have optical applications like Yaltrux, a comparatively newcomer in the ceramic material field. It is used since it is as transparent as window glass and can resist very high temperature. This white Tralox is a new material which is very similar to a window glass, but it has very high temperature resistance. Okay, so these are the applications. And then we have third type of advanced ceramics. So these are used in internal combustion engines, turbines, armor plates, electronic packaging, cutting tools, energy conservation and storage and generation. So these are the different types of applications. And some of the forms of this new ceramics are silicon carbide, silicon nitride, and then we have other forms like zirconium dioxide, bismuth carbon, silicon carbide again, and beryllium titanium alloy. Okay, these are the different types of advanced ceramics which are used in industry nowadays. So that is all about this non-metals. Like we have studied ceramics, and before that we have studied different materials like plastics. That is all for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.